But we're just going to go over, the answers to most of these. So it says identify the parent function. So the parent function is x squared, which is what we call a quadratic. And then the next quadratic function is shifted to the right. 2. It's right because it's negative inside. There we go, it focused. And then the other one is -4, so that is down 4. So it's your parent function shifted left, right, up, and down. Remember, our roots are where it crosses the x-axis. Oh, it's very delayed. Or frozen. Alright, so then it says, write one that applies to these. So y equals x is a linear. If you want to move a linear function down 2, you just subtract 2 from x. So it's y equals x minus 2. This is an absolute value. 4 units up affects your k value. So that's absolute value of x, 1 unit to the right. So if you do 4 units up, it's absolute value x plus 4. But then the last transformation moves it to the right. So that would be absolute value x minus 1. Close absolute value plus 4. So this is just the 4. And then that's the 4 and the up. Okay, to change it from standard to vertex, you have to find your negative b divided by 2a. So in this case, my negative b divided by 2a was 2. Here my b divided by 2a was negative 3. This b divided by 2a was negative 2 and negative 3. B divided by 2a is also the same as your h. So these two columns should have matched. Then I gave you some of the formal definitions, went back through some of the vocab we know. The vertex form of a quadratic is y equals x minus h squared, all multiplied by a plus k, where a is your stretch or compress as well as reflection, h is your horizontal, k is your vertical. So it said graph the following. So in number 1, that meant my h was negative 1. My k was negative 2. And my a was 2/3. So if you went back and did our table from the past, it was x minus h, y times a, subtracting our k. So 0, 1, 2, 3. So you had negative 1, 0, 1, and 2. And then your y went 0, 1, 4, 9. Subtracting 2. So that meant your vertex was negative 1, negative 2. Then you had a point at 0, and that's 2/3 minus 2. So that's like negative 1 1/3. And then you had a point at 1, and 4 times 2 is 8. 8 divided by 3 is 8/3. 8/3 minus 2. Well, that's really kind of like subtracting 6/3. which gave you 2/3. And then 9 times 2 is 18. 18 divided by 3 was 6. 6 minus 2 was 4. So you had 2, 4. Which gave you your quadratic. This would have roots between, and again, they would have roots between 0 and 1, which we can see here, as well as -2 and -3. Okay, and number 2, your vertex was at -1, -4. That graph is stretched by 2. So again, you have x minus h, y times 2 minus 4. So you had -4 as a point with -1. You have 0, and then that's -2. And then you had 1 and +4. And then you'd have 9 times 2, which is 18. 18 minus 4 gave you 14. And that's off my graph. So connecting your points, there is your quadratic. So the reason we're going back, we're looking a lot at these quadratics and how to graph them, is for our next unit. Here it said write the equation of the parabola, so you had to pick your point and pick another point on your graph to help you find the difference or the slope. So you would plug into your points, -3 equals a, x is 0 minus h, which is 2, squared minus k. Use that to solve for a. So you'd add 5, which is 2. 2 squared is 4, so you'd get 2 divided by 4, which made your a 1/2. So a, h, k, made your equation 1/2 x minus 2 squared minus 5. Over here, you did the same thing. So your vertex was -1, 0. Your y's were 2 equal a. -2 minus a -1 squared plus 0. So minus a minus became a positive. -2 plus 1 was -1, but -1 squared is 1. So you got a equals 2. So you had y equals 2, x plus 1 squared. And then this example is a calculator type question. So it says the strip is given by this equation here. The bottom left corner of the wall is the origin, and x and y are measured in feet. How far apart are the corners? How high are they? So the max height will occur at your vertex. So in this case, you could find your vertex. So your h is 25, and your k is 10. So that meant your vertex was at 25, 10. So that is like where the paper strip is going to come down. Now, the height of the strips in the corner are going to be kind of at your x, when x is 0, and your y-intercept. So you'd plug in 0 for x. Solve for y. So 25 squared times 0.008 gave you 15. So what that meant was that the height of the point was at 0, 15. Then at x is 25, it went down to 10. 25 represents the middle of the vertex. So at 50, your other wall would be back up at 15. So your streamers would look something like that. So the max height of the two corners would be at 15 feet, and they are 50 feet apart. Okay, and then a suspension cable from a bridge forms that parabolic curve. How far apart are the towers? How high are they? So this is kind of the exact same concept. You want to find for how high, where is x equals 0. So you take those values and square it, multiply it by 0.001432. So it is 649.684 feet high. And then to find out how far apart they are, it would be helpful to know where your midpoint is. So the midpoint is at 2130. So that means that 2130 times 2, or 4,260 feet apart. Because again, this 2130 represents the middle of the curve. So that means the whole curve is double the middle. If the towers were 4,000 feet apart and 600 feet high, then that 4,600, that means that my H value has to be 2,000. Because that has to represent the middle of the total length apart. So that's kind of like saying you have a point at 0, 600 and a point at 4,600. And then we know our vertex is at 2,000, but we don't know our K. In this case, the K was 0, so you could say that your K value would be at 0 for this one as well, and then have to just find your A. So you would find 4,000 minus 2,000, or 2,000 squared, and 600 divided by, that answer gave you a very, very, very teeny tiny A value of 0.0000015. And I think we're okay. But to convert from standard to vertex, you have to identify your A, your H. So remember, H is the opposite of B divided by 2 times A. And then your k comes from plugging that in. So vertex form would be y equals -7, x plus 5, because minus a minus, squared, plus 6. So again, h is -b divided by 2 times a. And k comes from plugging that in. And then you fill in your vertex form. So hopefully all of that was a review that you kind of remembered, that wasn't too challenging. Maybe you have to go back and look at one or two things. So what we're going to do for today is going to take those ideas, but now we're going to graph quadratics with shading. So we're looking at quadratic inequalities, which means we're graphing quadratics with shading. So go ahead and take out your notes that you just picked up, that the copy machine, had fun making. And let's look at that first example. So there are 3 warm-ups at the top of that page. Go ahead and do those 3 warm-ups for me now. Right? So we are looking at quadratic inequalities today. So that's why it's so important to do that review handout of graphing quadratics. So for your warm-up, you had 3 different types of equations. The first graph was a linear function who had a slope of 2 and went through a y-intercept of -2. I'm going to switch.